Hello guys, welcome to a brand new unit on proportions. This one is going to be really fun, and in class we will be doing a lot of hands-on activities. Okay, so today you will be learning on how to identify and write proportions. And this is the benchmark. Vocabularies for today will be equivalent ratios and proportions. This is really a review of 6th grade, but just to refresh your memory to make sure we know how to solve them. I'm going to go ahead and do this with you guys anyways. Alright, so here is an example. We have students in Mr. Howell's class. Maths class are measuring the width W and the length L of their faces. The ratio of L to W is 6 inches to 4 inches for Jean and 21 centimeters to 14 centimeters for Pat. And here we can write these ratios in different ways. So we can write them as fractions, which will be 6 to 4 or 21 to 14, and since both of them we can reduce them to 3 to 2, those are called equivalent ratios. So equivalent ratios are ratios that name the same comparison. That means they're equal to one another. Alright, let's go ahead and do it. Let me show you guys here what I'm talking about. Okay, so for example, we had 6 to 4 and we also had 21 to 14. Now we want to see if they are equivalent. One way we can tell if they are equivalent is to actually go ahead and reduce them. So if we divide this by 2, and this will equal to 3 to 2. And if we go ahead and reduce these by 7, their GCF, and this will also be equal to 3 to 2. So that means 6 4 and 21 14, those two are called equivalent ratios. Again, remember that equal means the same. So it's really similar to the fractions, but now we are talking about ratios, so we have to say ratio, equivalent ratios, but it's the same thing that we will do for fractions. Alright, so this is how we read the ratios. 6 to 4 is to 21 to 14. Alright, so those two will form a proportion. Now, two equivalent ratios, let me highlight what you guys need to copy down in your notes. If we have an equation that states that two ratios are equal, those are also called a proportion. So if we have two equivalent ratios, they will form what is called a proportion right here. So we could say that 6 to 24 and 21 to 14, those two will be a proportion since they are equal to one another. Okay. Alright, so again, if two ratios are equivalent, they are said to be proportional to each other, or they are in proportion. Now, let me go ahead and tell you guys different ways that we can determine if ratios are equivalent. Okay, so one way we can do it is to go ahead and simplify. So we have 24 to 51 and 72 to 128. Let's see if they are in proportions. So we reduce this by their GCF and we get 8 to 17. And now we again simplify 72 over 128 and we get 9 to 16. So will those two be proportional? No. So that means they are not proportional because they do not equal to one another. I will show you guys to the side also another way that we can identify if they are proportional. So for example, we have 24 251 equal, let's see if it is equal to 72 to 128. So one thing about proportion is that their cross products should equal to one another. So for example, what do I mean by that? If I have let's say 2/3 is equal to 4/6, now their cross product, that means that when I multiply 4 and 3, 4 times 3 will give me 12. Okay, and then when I multiply 2 times 6, again this only works for proportion when we are talking about proportions. 2 times 6, that is also equal to 12. So if their cross product is equal, then we know that those two ratios form a proportion. Okay, so if when we do 2 times 6 we get 12, 4 times 3 we get 12, so that tell me that they have a proportional relationship. Okay, let me go ahead and okay, so we could actually do the same thing here for those two numbers, and of course we already when we multiply those two numbers we will realize that they are not proportional. Alright, so go ahead and determine to see if this is proportional. Those two ratios are proportional. Now, two ways you can do it, I already showed you on the previous slide, is to find their cross product. If their cross product are equal, then they will be proportional. Or you can go ahead and simplify it. So go ahead and pause and try this. Alright, welcome back. So here we go. Let's go ahead and use the simplify method. So 152, 105 will be 10 to 7, and 9263, that is also 10 to 7. So yes, those two ratios do form a proportional relationship. They are in proportion. Alright, here's another one. Go ahead and try it. Alright, here's the answer. Those guys are when we reduce them to half. Okay. Again, all we are doing is reducing them, or we could do 54 times 144, 72 times 63, and see if we get the same result. Alright, so here is an applied question. This is really like if a lot of people that cook, if you like to cook, you are always constantly using proportions. So let's go ahead and read this. So here's the directions for making 12 servings of rice. Call for 3 cups of rice and 6 cups of water. For 40 servings, the direction called for 10 cups of rice and 19 cups of water. Determine whether the ratios of rice to water are proportional for both servings of rice. Okay, so if I'm going to make 12 servings. Okay, so here they want us to compare to see if the same servings for 12, 3 to 6, and for 40 people, 10 to 19, if those two are proportional. Okay, so the one for 12 servings will be, so the ratio for rice to water, again, rice to water, will be 3 to 6. And for 40 servings, the ratio of rice to water is 10 to 19. Now we need to see if those two are proportional, so we can put them together and see if they actually will equal to one another. So we can use the shortcut method. So here I'm going to find their cross product to see if they are equivalent. 10 times 6 give me 60, and 3 times 19, and that will be 57. So 60 does not equal to 57, so that means in this recipe they will not be proportional. The recipe here is not proportional, so our rice will probably end up being messed up. Actually, to go from 12 servings to 40 servings, we will have to multiply the whole recipe by 3 1/3, so we could get the exact ratio of how much rice and how much water to add for 40 servings. We'll deal with these more in the next lesson. Alright, so here's an example. Go ahead and try it. So here we have use the data in the table to determine whether the ratios of beans to water are proportional for both servings of beans. So go ahead and compare those two ratios and see if this recipe is in proportion. Go ahead and then come back and to check out the answer. Okay, well, welcome back. Alright, so here we have those two proportions. They are not proportional. How can we tell? We could actually, well, what they did here was they write them so they could have the same denominator. That is also another way we could compare them. Ratio was 4 to 3 and 13 to 9. So we can also rewrite them so they could have the same denominator. So we could multiply this by 9 and multiply this by 3. So this will equal to 36 to 27, and this one will equal to 29 to 27. Oops, 39 to 27. So that means 36 and 39, those are not equivalent. Or we could just do, again, find the cross product. We have 4 to 3. Is it equal to 13 to 9? Again, 13 times 3 will give me 39, and 4 times 9 will give me 36. So again, they will not be proportional. They will not be equal to one another. Alright, another way that we can find equivalent ratios is again similar to the fractions. We just multiply or divide them by a number. So let's do an example. So example, we have 3/5. We can multiply, for example, by 2, and we will get 6/10. And we can have 3 to 5 is proportional to 6 to 10. Here's another one, 28 to 16. This one we could actually reduce it, which will be by dividing it by 1/2 GCF. And when we divide by 4, and we will also get another equivalent ratio there. Alright, so go ahead and try to rewrite as many, at least two, I'll say at least two equivalent ratio for those two. Alright, so let's go ahead and take a look at some examples. So we could write down 4 over 3, 4 to 3 for this one by reducing it. Also, we could multiply by 2, multiply by 3, you know, whatever number we want, whatever factor. And here again, this one was reduced, so possible answer will be 27 to 10. Or again, if we want to make it bigger, we would multiply. Alright, so that's it for today. If you guys have any questions, please post them on Edmodo, and I'll see you guys in class. Have a good one. Bye bye.